of the square root of 9x fourth to the fourth plus 1 over 4x squared plus 3. Let's go ahead and evaluate. Well, I can already tell that it will use L'Hopital's rule, and they aren't really looking for much on the AP exam, so I'm just going to put that there, which means that the derivative which means that the derivative hold on, no, I can just already know what's going to happen now. Because the degree is going to be 2 and Water is flowing in the tank at a rate of R of T, where R of T is measured in gallons per minute and T is measured in minutes. The tank contains 15 gallons of water at time t equals 0. Values of R of T or selected values of T are given in the table above. Using trapezoidal sum with 3 intervals indicated by the table. What is the approximation of the of 3 subintervals? So there's 1, 2, 3. 1, 2, 3. So that means 1 over 2. 9 plus times 4 plus 3 times 1 over 2 times 6, 4 plus 6 plus 2 times 1 over 2, 4 plus 3, which means 15, 30 plus 10, 5, 15. This is 7. So this is 45 plus 7, which is 52. The slope of the line tangent to the graph of y equals ln 1 minus x at x equals -1 is, if I had to guess, actually I don't need to do that. The slope of the line tangent, that's just asking for y prime of 1, so y prime is equal to ln 1 plus 1, sorry, 1 minus x, no, that's y, 1 over 1 -1, so that means y prime of -1 is equal to -1 over 1 minus -1 over 2, -1 over 2. Which of the following so I guess this is a question where L'Hopital can't be a thing. No. Oh wait, no. That'd be 0. Oh, 3 to the n. It's gonna be this one. Even if you L'Hopital it an infinite number of times, it's still gonna be infinite. Well, not really, but you get the point. Yeah, that also can't be it. Yeah. The definite integral from 0 to 4. That. Hold on, I'm trying to remember. No, never mind. I could just use u sub u equals x squared plus
plus 9 du is equal to 2x plus dx. Dx is equal to du 2x. I can put this into here, which is just 16 plus 9, 25. And in here, that's just 9. I'm just going to skip a couple steps. Which is just 1 over u to the 1 over. This is just going to be u to the negative 1 over 2 dx, which is just 1 over 2, sorry, du. U to the 1 over 2 from 9 to 25, which is just 5 minus 9. Oh, sorry, 5 minus 3, which is equal to 2. Pretty cool question. Let f be the function with a derivative given by f prime of x equals negative 2x over 1 plus x to the x squared to the second power. On what interval is f decreasing? Interesting. X would have to equal 0. X would have to equal, well, at least one of the x's would have to equal 0. So that's 0. So let's try negative 1. That's 2. 1 minus, 1 plus 1, that's 2, 4. That's positive. 1, negative 2, positive. So positive, no, sorry, that is negative. So we know this is wrong, and this is wrong. Also, this is wrong, and it's 0 to infinity. E to the x plus e dx. Again, e to the x dx plus e to the x, sorry, e dx, e to the x plus ex plus c. The graph of the function, which of the following could be a graph of f prime and the derivative f? It starts negative. It starts negative, bottoms out, then positive, then negative, caps out, then negative. So it's not going to be this because it starts off positive. That could be it. It's not this, and that's odd function, so no. If 0 c1 was area enclosed by the graphs of y equals 0, x equals c, and x equals 1. So let's go ahead and create a graph. equals 0, x equals 1, what the hell? X equals c. C minus 1. X minus 1 dx. This doesn't make any sense. Wait, no, I could just be doing this. C to 1. Because that would just be an interval. And then 1 dx, which is just x c to 1, 1 minus c. 1 minus c. No. 1 minus c dc. Or actually, no. C would be constant, so it would be 1 minus x dx, and then that's x minus x squared over 2 from c to 1. So 1 minus 1 over 2 minus c minus c squared over 2. This is actually a pretty cool question. Oh wait, it gives me the, I'm stupid. I didn't read. The reading comprehension devil got to me. 1 over x dx, which is just ln x from c to 1, which is just 0 minus c, minus ln c. And it could be ln 1 minus ln c, which using logarithms would be 1 over c. I had to convolute an answer because they're moving. Immediately, this is wrong, this is wrong, and this is wrong. It's going to be one of these two answers, which is just d dx equals 1 over 1 plus x squared negative 1 over 2 square root x. Oh wait, I forgot about that. So this and this cancel, so it's this. If y equals f of x is the solution to the differential equation dy dx equals x e to the x squared with the initial condition f equals 0, which of the following must be true? What the hell? That's a non-elementary integral. I fucking knew this. Oh no, you're not finding the derivative. No. Why are they giving me a non-elementary integral? F of x 2 plus 0 to A function f of t gives the rate of the evaporation of water in liters per hour from a pond where t is measured in hours since 12 moon. Which of the following gives the meaning of the integral from 4 to 10 f of t dt in the context described? Total volume. The first derivative of the function f is given by f prime 3x to the 4th minus 12x squared cubed. What are the x coordinates of the points of inflection? Okay, then I have to derive that once. 12x to the 3rd minus 36x squared, which is just x squared, 12x, 3x, x minus 3, which is equals 0, so therefore x is equal to 0, and x is equal to 3. Let f be the function defined by f of x equals 1 over x. What is the average value of f on the interval? It's asking me stuff. Which is just 1 over 2. Oh, sorry. Definite integral. One over 2 ln 6 ln 6 minus ln 4, which is just 1 over 2 times ln 6 minus 6 over 4, which is just 1 over 2. The points 3, 0, x, 0, x, 1 over x squared, 3, 1 over x squared are vertices of the rectangle where x is greater than 3, shown in the figure above. Are vertices. Okay, so that means if I plug it into this function, I should get this vertex for 3. Oh, this is an optimization problem. Oh, we didn't do a lot of optimization in my calc class. I guess. Right, so you have a rectangle. area of a rectangle is the area of a rectangle is length times width, right? And we're looking for this. The perimeter is 2L plus 2 with we're looking for length. We're looking for length, so that would be, I can just plug it into here. No, we're looking for one specific thing, meaning that I would have to do I'm confused. Optimization problems. I barely did any optimization problems, so A equals L times W. It can't be. Oh wait, no, I can find one with the length right now by just doing just plugging this thing. So that's 1 over 9. So A equals 1 over 9 W. Therefore, I can plug it into here. P equals 2 times. W equals 4A. No. I'm confused about this question. I don't think I'm going to release this. Optimization. Does the max have the maximum area? Oh wait, I could just plug it into the. I'm stupid. Okay, so that's 1/9. I could just plug it in. 1/9 times. No. 1/81 plus, or times 9. Oh, I'm stupid. I'm stupid enough to not see the. Actually, there is no value. Unless you get infinitely close to. There is no value x. I'm embarrassed I took that long. Which equals 0, that is 2. No, actually. Because that's an odd function, therefore it's plus or minus 2. Let h be the function defined by h of x. Yeah, sine squared. Which of the following is an equation for the line tangent to the graph where x is equal to? Okay, so h prime of x is equal to d dx of pi over 4. How do we do this Taylor series? Excuse me. I'm just gonna do this. The table. Which of the following must be true? F has no critical values. I don't know about that. But let's see. It's increasing, increasing, increasing. It is indeed increasing, so that could be a maybe. F prime of x. Again, maybe. prime for all values. We don't know that. F prime, F double prime is greater than, again, we don't know if it's going to be like that for all the values. I'm going to do this. Particle moves along the x-axis time t is greater than or equal to 0. The acceleration of the particle a of t, so we have the xl equals 15t square root t. Is 15 square root t. The position of the particle is 10 when t is equal to 0. The position of the particle is 20 when t is equal to 1. What time is the particle? At what velocity is time equals 0? I could set this up as a differential equation and get the 15 square root t dt, which is equal to 15 square root t dt, sorry, t, which is equal to 15 times t 3 over 2, wait, no, 2 over 3, 3 over 2, plus c, and that's 5, so 10, 10t, 3 over 2, over 3, and we already know that c is 10, so what time is it? It equals 0. Oh wait, no, that just took, oh, that just made things complicated. In that case, I would have the integrated ones, like find the definite integral ones. So that'd be 0 to 1. And the position, +15. Which is equal to 5. Which of the following is a solution to the differential equation dy dx is equal to 2xy over x squared plus 1? That's definitely one. means if I differentiated it, first of all, let's find for this differential equation to dy dx at 0, 1, 2xy x squared plus 1 is equal to 2 times 0 how the hell? Wait, no. That's just equal to 0. Or 1. And that's 0 plus 1, so that's equal to 0. If I differentiate it, that couldn't be right. Y prime is equal to 2x, so maybe ln1, that's another one. Wait, no. No, that couldn't happen. 1 plus, again, same thing with I'm just gonna say this one, because y prime 2x makes sense. Sand is deposited into a pile with a circular base. The volume V of the pile is given by V equals r cubed over 3, where r is the radius of the base in feet. The circumference of the base is increasing at a constant rate of 5 pi per feet per hour. When the circumference of the base is 8 feet, what is the rate of change of the volume of the pile in cubic feet per hour? Remember C. Remember C is equal to 2 pi r. So that means dc dt is equal to 2 pi dr dt. When the circumference of the base is 8 pi feet. When the circumference of the base is 8 pi feet. Also dc is equal to 5 pi, so 5 pi equals 2 pi dr dt, which means if I divided 2 pi, this and this would cancel, and this would cancel. So 5 over 2 is equal to dr dt. What is the rate of change? Really similar thing. And 8 pi is equal to 2 pi r, which is 2 pi, this and this cancel, this becomes 4, so r equals 4. And dv dt, first of all, v is equal to r cubed over 3, which means r that'd be r squared that would be r squared dr dt, which means dv dt is equal to what, 4 times 5 over 2, which I did something wrong. I'm too lazy to figure it out though, so I'm just gonna keep this question answered eeny meeny miny mo. Non-existent. Non-existent, because even if we take it with the definition of derivative, it's still a limit. I can't just not do it. It's still a constant, so it'd be non-existent. Oh no, actually it'd be 0. Or actually, no. Hold on, so e minus 1 minus e minus 1 for 0. No, it'd be non-existent. Unless it was e to the x. Let the function given by f of x. This is kind of boring. I can't stand derivatives now. E to the xy minus y squared equals e minus 4, and at x equals 1 over 2, and y equals 2, dy dx is equal to... So that means if this was the derivative, I would have to use product rule, so that's x dy dx plus y e to the xy minus 2y dy dx equals 0, because those are constants. This is why you group things correctly. Better correctly. xy minus 2y dy dx equals 0. just times where I have to substitute in right now, so 1/2 dy dx plus 2 times e to the times e minus 2 4 dy dx in which I can do 1/2 e dy dx plus 2e minus 4 dy dx is equal to 0, which means dy dx 1/2 e minus 4 dy minus 4 is equal to negative 2e. Which means dy dx is equal to negative 2e over 1/e minus 4. 1/2 negative e four. Again, that was just a guess. Let f be the function that is long polynomial, well, not really long. Inverse g of 3 is equal to 1. What is the value of g prime of 3? Okay, so that'd be f. So f of 1 is equal to 3. Okay, so let me find f prime. F prime of x is equal to 3x squared plus 2x plus 1, which means that f prime of so that must mean that 1/f prime of g of x and we've already established a g of 3, 1/f f prime of g of x, which is 1. So therefore f prime of 1, f prime of 1 is equal to 3 plus 2 plus 1, which is equal to 5 plus 1, which is equal to 6,